Hello, everybody. Hello, everybody. Hello, Java developers. Hello, everywhere in the world. We are here again in another session with our guest, Muhammad Taman. Hi, Muhammad. Thank you for accepting our invitation.
With all pleasure, my bro.
Thank you so much. Let's give a brief introduction about Riyadh Java User Group. It's of course, a JUG like other JUGs. We here organize sessions, meetups, talks about any Java-related topics. We invite any speaker in the world is most welcome. We had a couple of amazing sessions in the past. Please do check them in our YouTube channel. Today, we have a special guest, Muhammad Taman, is a solution architect, is a Java champion. He's also a GE ambassador. He's an author. He's a speaker over the world. Today, he accepted our invitation, and he's really, appreciated for that. So today, he is going to talk about a very amazing topic where how to do the transition between monolithic and microservice architecture. So the stage is yours, Muhammad. All the best. Good luck.
Thank you very much, brother. It was my pleasure to accept this kind of invitation because it's very special to me. And first time to speak to Saudi, community members specifically, and welcome to anyone who is joining internationally. As Muaz says, that my name is Muhammad Taman and I'm working as a solution architect. My background mainly in Java, and this is why in a humble way, I'm Java champion. I'm speaking about technology, not just about Java, but in different technology, different topics about like database, cloud, distributed systems, architecture, many things. And this is why I also write about it. So the best way to get most of my writings, I write for different like magazines. Previously, it was like Java Magazine, IBM Thoughts, and IBM Work, and Developer Work, InfoQ, DZoon, and I have some books that are available in the market. So this is how I share my knowledge. You will find me in some other places, and there is a lot of sessions. So today's session, actually, this is my inner thoughts, and me and my team, we were working in some transitions because I'm working for Magna, and Magna is a company that internationally is not IT company, actually. It's car part manufacturing company and car producer company. So what we do as a company, we are producing car parts that almost most of the major customers for us, like domain consumer, like let's name few of them, like BMW, Mercedes, General Motors, Honda, Toyota, name any car vendor, and sub vendors of those, Volkswagen, Chrysler, some of these names that you can get familiarized with. So we are producing car parts as well as the whole car in our factories. So this is the only almost company in the world who's producing car parts initially, but also take a business line from major companies. Like, for example, in Magna Steyr in Austria, the 5 Series of BMW, it's only produced by Magna for BMW Germany, and then it's shipped for that. What does it mean? It means that we have a lot of like different domain. It's automotive domain as a general, but inside we have a lot of problems that we need to tackle, from quality, from production, from warehousing, from ERBs, financing, HR, logistics, ARBs, name it, and the core of all of these assets and data and application. And the market is moving fast. So we have to come up sometimes we have a lot of legacy systems because it was non-IT, and now the IT becomes one of the major pillar of this company. So we are trying to make things right as much as we can. So we have, old heritage of debt, of technical debt and things legacy, and we would like to move it to modernized way from on-prem to cloud environment. So I'm going to share with you some insights here about what we are going to do. So, again, hello everyone, and thank you for joining me today. So, our presentation today is called Tactical Forking, which is a strategy for implementing microservices that enhance your software development strategy and allows your software and your team to grow. This is very important to understand. It's also enable you to deliver a new feature immediately using multiple teams and with a controlled transition to microservices based architecture, because sometimes we cannot move directly our applications and we think our like monolith application or the the big pile of one application is easy to divide, then convert it to microservices, then but after some study and thoughts you will think differently. So I am Mohammed Taman, solution architect at Magna. If you just joined recently, I'm an instructor and author. I'm excited to show you how to use the tactical forking as a software development strategy and give you a realistic view of the possible challenges that we might face or you might face when this transitions, so how you can solve it. So let's get started with this presentation. Buckle up and let's go. Before I move, if you want to just get in contact, which was a great pleasure, this is my domain knowledge areas that I'm talking like I'm working on AI, LLM. I'm working as a full stack. Yes, I still do hands-on coding as a proof of concept. If you're a solution architect working with a team, it's a good idea as much as you can to understand the mechanics of the software, pieces and architecture. So if you can do proof of concept, you will help yourself, familiarize with the new technologies and also gonna be help your team. As well as I do this proof of concept, I put it in my GitHub. You can look at it, or it will be like blueprint for my team to take it as a starting point and continue developing that, POC. So I didn't want to share my social media. It's much easier to get it all, whatever you want. So search my name on Google and you will get everything about me. I will be glad to have your connections. So our agenda today is composed of like actually 5 categories. And those categories are, we're going to speak about what is tactical forking, when to adopt tactical forking strategy, and how to adopt it, because there is no silver bullet solution for everything. Microservices is not solution for everything. So we should know when to use what exactly. This is very, very, very important. Tactical forking also impact on team and development, how it will affect us. If there is any cost, if there is any challenges we will face, we will talk about these tactical forking challenges as well, to be aware upfront what we're gonna face in order to take it into consideration. So first of all, what is tactical forking? To explain what is tactical forking is and how it can be used as an approach and the strategy for growing your software, we must first look at the situation where tactical forking becomes an option. So to illustrate this, you have your typical software architecture. There is a back end, and some other front-end applications, either separate application or mobile application, or that are served by the backend. As your software architecture become more successful as a product, you start adding more feature. This backend system, which contain all your business logic and apps functionality, becomes increasingly large. This type of extensive, organically grown application is sometimes referred as a monolithic application. And you know all of this. But just to understand the context, with this continued growth, we usually start experiencing the challenges associated with this monolithic application. One of the first signs that we need a new approach and strategy is when we change our application in one place. For example, some functionality for our mobile application, and we are trying to change it and accidentally break other functionality for related web application. So now we need to take a break and think about, like, I'm just because this whole big pile of mud serving whole applications. So one change might affect the others. So we are screaming and we need to make sure that we are not changing functionality. So in addition to this reliability, actually another indicator for a new approach might be that it can become quite challenging when we start growing our team. Then we need to add features more, then we need to add more teams. And this is not an easy because while we are growing our team, we need to grow our software. We find that because we share the same code between multiple teams, which is something normal, but we are sharing the same. So the teams cannot work autonomously. This is very obvious and waste much time ensuring changes are committed correctly. We have to sync. This is make use of our efforts, synchronization, and we want to make sure that everything is committed, successfully. And even then, the odd issues and all bugs and some other bugs will leak into our system because we are all changing the same code simultaneously. So this is the second indicator of requiring a new approach. The obvious strategy change in this situation where we are dealing with this sizable monolithic application that's being worked on by multiple teams is to start breaking up the application, code into something like microservices so that each team has a part of the code and that relates to their business domain. This is very important to understand. Now this is the sign that we have multiple teams, we have breaking changes that happens. So now we want to fork each domain part of this application to give it to a specific team in order to make the changes autonomously without affecting each other. But the problem actually with most of these microservices migration strategies is that they always assume that your extensive monolithic application is internally well organized, which is not always the case, and structured into components that relate to specific functionality. You will be lucky if you have this and parts of your business. However, this is not always true. As I have seen in many applications, just developers come to add the functionality and doesn't care about layering, modularity, or whatever it is. So this is what we end up, which is why some microservices migrations start failing. Yes, I was working for some companies and trying to migrate, and they failed and bankruptcy because they tried to make this migration and it goes wrong. They spend a lot of time and money, and the investor wouldn't like to invest anymore. Then we took it in order to make this gap analysis and assessment in order to identify first the domain. And it was even found that there is a lot of microservices has been taken out of this monolithic application up to 45. And when we did assessment, we found that we can reduce it to 20, actually one microservice. And even this, after some development, we merged some microservices to become finally a 16 microservice by far. So this is the danger of thinking about very tiny small functionality, just we move it as a separate microservices. It doesn't work because microservices comes with challenges, big challenges. So it's not the solution for everything. So your application might externally, as you can see, blocks lovely externally look well organized into different functionalities in different business area. But when you look at the code internally, all the code might be conjoined and coupled. And it's hard to separate those different business functionalities into separate application and microservices. The good news is that this is where tactical forking becomes an option. So it becomes an alternative approach and strategy that you can use to grow your software and your team. So this approach involves giving a copy of the entire code to each of your teams and having some routing mechanism that routes all the incoming requests to your system to different parts of your applications. It gives an illusion for one back-end system while giving your team this, their version of code that they can develop autonomously. This is the basic idea of the microservices having something like API gateway or something like this. We will speak about these challenges and how we can, because there is many challenges, but the idea is I will give each team the whole entire part of code. This is the first step to use tactical forking, the entire code base. So now you can ask a question. Will be duplication. Yes, but there is also another way to tackle this problem. So not only can each one of your team now start adding new features to their versions of the code without having to wait for the microservices based system, actually, they can also do in the background start stripping away some code that's not related to their specific business domain and their particular business functionalities and areas. So, with the tactical forking approach, you will eventually end up with microservices based system. But the key advantages is that you won't have to delay any of your new features. The migration to microservices becomes a background task while each team develops its version of the code with new feature. One most important thing that I would like to mention here, that tactical forking is not something new actually. It was first introduced by a guy, individual called Fausto de la Torre, and he was like a director of software for Thought's work, and he published um, some thoughts about this kind of idea, and I found it's very interesting. This is the link for that, and I found it's very interesting to take it into consideration to have it as a pattern for some specific old, monolithic application while we start hiring more team to get into the business and up to speed of the business, adding new features and modernize the old software. So just I wanted to mention that because it's very important. So before we move on the next section, here are a summary of all the key points mentioned previously. So as you can see, the tactical forking is an approach or strategy for software architecture and also to progress your software architecture. Thirdly, it's a progress to add the new features, progress for the purpose of eventually having microservices, and finally, immediately support development by multiple teams. So I hope it's a clear for this point, and let's move forward when to adopt tactical forking. So in the previous section, actually, we introduced tactical forking and briefly outlined situations in which it becomes an option. By considering this option, we should highlight the specific scenario in which tactical forking will be helpful. I will do this by providing a clear criteria. You can have it in paper, or when I share the presentation, or you can watch again the video, you can have this as a checklist for you, as a criteria that will help you assess its suitability for your software. Again, the first question from this criteria asks if you need a modular software architecture, like a microservices-based system. You remember I have mentioned previously that you have to be careful when to use what. This is very important. So this modularity allows you to change and upgrade the different business area within your software separately. This separation will then ensure that overall reliability of your system, basically changing one component. Changing one microservices won't break other part of your software architecture. So this is the criteria that you can ask and assess that can help you. Either you want to move to microservices based architecture, or even though modular monolith, for example. So because I know monolith is an ugly word for everyone, but for me it's a marketing area to just make the people move to microservices, because this is the marketing, like, campaign to start using a new software that support microservices, which is I don't like. There is a software pattern exists. There is no wrong when we have monolith application for many concept like proof of concept, time to market. It's much easier to have. There is no too much load on the application, and they do some basic services, and there is no big changes in the software will happen, so you can have it like this. But if you would like, there is a lot of changes, there is different autonomies of the team distributed, and there is a scalability issue. Sometimes we could have part of the software is monolithic and the other part has been extracted out. This is where it comes in the middle, something called modular monolith. So you design your monolith as a modular application, separation of each business domain internally in a way that they are modular. So it's much easier for you in the future to extract this domain into outside to be microservices based. Then it's still communicating through the routing mechanism to the other part of the systems to complete the overall functionality. So this is very important, always to ask, because in architecture, it's about the trade-offs. It's not about what the best to use, and what the trade-offs out there, and why I have chosen this specific, architecture or component to serve our, problem. So another reason actually for implementing this kind of modularity and separation may be to enable multiple teams to work independently, as I mentioned to you, on growing and enhancing different areas within your software with minimal friction. Once we have answered this question about the need for modular software architecture, the next question in our tactical forking criteria is your software's code base logically modular? This is very important. So in other words, does your software have distinct business areas and function that can operate independently within their own functionality and data weights, like separate logical modules that are separable into something like microservices? Do you have something like this? This is very important. Most of the cases, this question actually is very crucial, because you can easily have an impression of separate area within your software. Still, they are all working together to provide data and functionality. And individually, they need more weights in terms of data and functionality to be recognized as independent logical modules. So once we have established logical modules, let's assume that we know which module can have which functionality, and we establish it. We must answer the following next question before tactical forking becomes an option. I told you, you have to logically start answering all the questions, then your ADR architecture decision record can be fulfilled exactly with those kind of clarifications about your final decision. So again, the next question is, are these logical modules physically separable using traditional technique to separate code? So if they are easily physically separable because you have a well-structured code, which is I doubt most of the time, use traditional technique and avoid technical forking, which means you can just take each part and start working on it, as it won't benefit you in this situation, the technical forking. So, but however, in most cases, technical forking is the only option, because even though you have a logical modules They are physically too tightly coupled together. The code is too physically intertwined, where those logical modules overlap, making it hard to separate quickly. Therefore, traditional techniques to extract these kind of modules into microservices won't work or will take too long. And this is what happens with the project that I told you, that bankruptcy. So this is where tactical forking becomes viable. We have logical modules that are not physically separable immediately into something like microservices. Then we can consider this option. So when to adopt tactical forking? So I have summarized this. I have summarized the questions for you here in a simple cheat sheet so that you can ask yourself the same questions to determine when to adopt tactical forking. If you answer yes to all these questions for your software project, tactical forking might be the viable strategy to grow your software and your team. And this is very important. So I will not repeat the summary. You can take screenshot of this and you will find it when we share the presentation. So let's move to the next section and we will examine how to practically adopt tactical forking as a strategy for this purpose. I will not ask you for questions. I will leave the question at the end. Because sometimes I will answer questions during my presentation. And if there is more question that I didn't answer, I would be very glad to have your question later on. So how to adopt tactical forking? Okay, so by now, you know what this tactical forking is and when it becomes a viable option for you. The next question is, how do you practically adopt this approach? So the first step is to evaluate what you would need to copy your clone so that another team has a copy of the software architecture that they can independently grow and own. So what do they need actually? Do they need copy of the backend APIs and the backend and backend database only, or do they need a copy of the entire front end application, the backend API and the database? Which part they need in order to facilitate all of this kind of working mechanism for each team? In your average scenario, you will only need to clone the backend API and its database, as they contain all the data and functionality, i.e., all the business logic and the main things we want to grow and enhance. Usually, the front end application is only a thin layer, okay, and therefore, in this example, we only focus on the backend API and the database, because this is where the functionality and the data related to domains resides. So the front end, it's like one application communicating to backend, so we don't need to give it for each team. There is only one team will be responsible for maintaining the front end. Before we physically actually clone anything, the next step is to identify the different business areas, as we have explained before, within your software as the logical modules, which we discussed in the previous sections. So depending on what area you will work on and how many additional teams you have, we create a copy of the backend API and its database for each of these business areas in your source control. So now you have to create different source control, name it with the business domain functionality. You have a copy of the database and the entire backend API. While we are talking about cloning stuff in source control, tactical forking, known as a tactical forking because it borrows the forking aspect of its name from the source control terminology. In the source control terminology, as all of you knows, forking means creating a copy of the code as a separate branch that can be worked on independently. So this is where the name came from. And it's not only the code you need to copy, by the way, in the source control for each team and each business area, but you also need to create a copy of the entire deployment pipeline for each new clone version of the code so that each team can work and deploy changes independently without affecting each other. So we cannot have different code base, then we have the same pipeline. So each team needs to have its code in source control, as I have mentioned before, and its build server configuration to independently build its version of the code. They also need their deployment server configuration to independently deploy and release their code versions. Ideally, they also need to have their environment and test environment to independently verify their changes in the term of upgrading and fixes. Once we have tactically forked our code and deployment pipeline into business domains, we will have this big picture. And I hope that you can understand now, it's not about the source code, it's about that the whole entire process of deployment build, on different deploy on different environments to verify your changes accordingly. We then need to ensure we have a clear ownership. This is the most important part. So, what development team own what business domain? Our team can work independently because they have their own code and deployment pipeline. Yes. And when they need to work together, there is a clear ownership and no confusion around who they need to work with. So this is like if I have team A, B, C, each team can greatly work independently, as you understand, but they also need each team need to know which business domain the specific team or lead responsible about, so they can get back to them if they're working together, or also they are communicating and or integrating together. So this is very crucial and important. So once the team are set up, the next stage of fun begins. They can start enhancing their versions, get their hands dirty with the code and specific areas related to their business domain, and begin deleting parts. It's always fun to delete, but make sure that you don't delete some of the code just to make it like naked and you lose the functionality. I'm just joking. So begin deleting parts of the code outside their business domain. This process of enhancing and stripping away code is known as a refactoring. We love do refactoring. And refactoring without test cases, I always like to introduce test cases before I start typing out to make sure that I didn't break the functionality that I'm working on, so I can delete with confidence. So you can see that in the green areas, boxes, each team has added new features or enhanced existing ones, and the gray areas represent the code the team has to start to delete. The deleted code related objects and data are removed because they are outside the business domain of the team's knowledge. Second, once we have this, we need to make a communication between the front end and the back end. So once we have these kind of new enhanced versions, although we have multiple copies of the same original code, we still need to give the impression of one working back-end system. We can use a routing mechanism specifically configured for our tactical forking strategy. Actually, it would take incoming traffic and intelligently, forward the traffic for a specific business area to the correct clone copy of your original software architecture that now represent a particular business domain. Thanks for our routing mechanism, because our front-end application will be obvious to the fact that they are now talking to multiple backends. So fooling them into thinking nothing has changed, because we will have one single part that receive all the incoming requests and just forward to the different, business domain backend. So this routing mechanism can take many forms, by the way. You can have your custom backend for front-end API that carries out this functionality, or you can have particular cloud-based component like an API gateway to do the same. You could even have some very basic as a load balancer that allow this configuration to happen. So how to adopt tactical forking? Now I have described how tactical forking can be made to work at a very high level. Still, you can use this example as a starting point for planning with your engineering team. This summary will help you will help you as a quick reminder of all the needed steps that you need to take care of when adopting tactical forking. So tactical forking impact on team and development, definitely it will have impact. The previous section, we examined how adopting tactical forking to grow our software. In this section, we will discuss the impact of the strategy on our team and software development, from cost, number of people, how we can adopt and adapt to the new strategy. Everything comes with the pros and cons. So one of the first things we need to consider is knowledge handover. This is very important. This is because it doesn't matter how controversial your software architecture is, if it is an extensive system, it's bounded to have a subtle details that must be communicated to other teams that inherit your code. So when we carry out the first step of tactical forking, which we covered in the previous section, we give each team a copy of the software and their deployment pipeline. As a part of this, we also need to do, the knowledge handover. This is very important, as I mentioned. Your application is extensive and has many configurations and subtle details about how it works and how the data works together. When we copy a code and give it to the another team, you will also need to hand over all this knowledge as part of the handover, and can take time. So although I have said tactical forking is an excellent way of getting teams to enhance your software quickly, that's still true. Still, the greater your application's configurations and data complexity, the longer it will take new team inheriting your code and get started due to these knowledge handovers. The other impact of tactical forking actually that the need to be considered is the impact on the resources. You will need more resources to support all these extra clone software architecture and extra deployment pipeline. These are data centers, resources like infrastructure, hardware, software on the cloud, on-prem, and also you will need extra engineers to support all this growth. So although tactical forking is a quiet way to grow your software, in addition to the setting up time, you will also need extra funding for extra resources that you will need to consider. Another impact of tactical forking strategy that we need to think about is the impact of missing data and dependencies. So as the team take their copies of the code and start enhancing their business domains and deleting code and data outside of their business domain, there will be scenarios where the data overlap. Indeed. So for example, when generating an order report using a new order API, we might need the product names stored as a part of the stock API and maintained within the stock API database. Within the order API, database, this data is missing because this order API no longer maintain it internally, and we have deleted. And it was deleted because it's outside of the order business domain. One solution in this scenario is to call the order API for missing data. So when incoming requests comes in and you need additional data maintained by different API, you make a call to that and API to retrieve the data. This is pretty obvious and easy. However, this comes with a cost. You now have an API calling an API, which means your response to the calling application will be slower. Although this is an option, the impact of the performance shouldn't be ignored, and it's very important. It would be the best to use various technologies and design patterns to negate this impact. And let's see how we can do this. For example, another solution to this missing data problems is to use something like a message broker to share data. So every time data is created or updated, a copy of the data is placed on the message broker. If another API or microservices needs a copy of the data in their database, they can take a copy of that data from the message broker. So hopefully from these examples, you can see that although tactical forking, again, is very effective strategy for very specific scenario, as I mentioned at the beginning, it impacts our team, software development in general, and we have to come up with extra resources and solutions to deal with this impact. So be careful when to choose what. But it was valuable for us in specific scenarios to move to microservices-based architecture because the business needs. So now let's examine the tactical forking challenges. So in this section, we will look at some of the challenges, i.e. the disadvantages of adopting tactical forking as a strategy to grow your software. Because I told you, we have always to give the disadvantages in the architecture, and this is why we have to document all the decisions we have made during the architecture. So I have a big document including the solution of non-functional requirement, and based on the bigger part of the technical requirement, the most of the document actually we are trying to mention the trade-offs between different solutions for high scalability, high availability. Is it like consistency of the database? Why we choose this model? Why not the other model? Why we only have master data and like replicas, not multi-leader, right leader? All of these kind of things, how the data will synchronize geographically in different regions and different availability zones, and so on. This is very, very tough, but we have to mention the trade-offs, so we making sure that we took all the decision in the right way. But by the way, even though we have made some wrong decisions with the revision, and while we are moving into the real application, you will figure it out many things. We change, update accordingly the architecture diagram, because not only diagrams, the architecture document, because this is the contract between development, testing, infrastructure team, the business people, and also the architects who put the framework with the team to understand that this is the main parts of the things has to, to work in this way, integration patterns, what is the output and input of every and single even integration source and destination. So let's see some disadvantages to understand, so we know when we can take it and we know also what we have to tackle. The first issue concerns code quality. As part of the strategy, we stripe away some of the existing code to create a new APIs, a new smaller microservices specific to the business domain. So the problem with this approach, especially if you are coming from legacy application, is that you keep much of the legacy code. And so regarding code quality, your new microservices will be only as good as old monolithic backend API and the backend database. So if you previously had poor code and database standards, it will leak to your new system. So be careful of this. So as I mentioned, you would inherit many of these poor standards into your new microservices. However, you can tidy up the code and improve the design by adding new features. But with deadlines for new features, we all know these ambitions actually sometimes need to be materialized. Yeah, I'm working in such tough environments. So always like I need the software 1 week before, not yesterday, 1 week earlier. So another challenges associated with tactical forking is centralizing shared components. Even though each team has its code and deleted code outside of the business domain, common code and files must still be shared between the teams to avoid duplication. So to avoid duplication, this common code and set of common files must be extracted, centralized, and shared between the teams as maintained centralized component libraries or packages. A team will be needed to be assigned to extract and centralize this code. The team must also manage this code long term as a centralized component with its deployment pipeline. The challenges here obviously comes from the helping the team coordinate the effort to identify, extract, and centralize this component so that they can be used by all of the teams. Previously in this presentation, we also highlight the impact of local missing data that has been separated into separate business domains, i.e. a separate microservice. Now, we give an example of the order API needing a product names when generating an order report. Product names stored in the stock API and no locally in the order API anymore. So as we mentioned, the good news is that there is a solution to share data between microservices. The challenges here, however, is that we have solutions, but this solution will slow down our tactical forking strategy. Why? Solutions like microservices to microservices calls and the use of messaging broker to share data all require specific technologies and design patterns before they can be implemented with the desired performance and reliability. So yes, tactical forking is a quick way, again, of growing your software and supporting multiple teams. Still, many new technologies and design patterns might be required to support the new tactically forked software architecture. So, and again, to give you a head start with your tactical forking strategy, here is the summary of all the key tactical forking challenges mentioned in this section to give you a starting point to formulate your plan for these challenges. Actually, by reaching here, I have almost finished my presentation. I am very glad to have your questions. Thank you very much for attending and listening. I hope that you enjoy it actually and find it useful. So any questions if we still have some times?
Yeah, thank you so much, brother Muhammad, for this amazing talk. I think Amir Hijazi has posed some question saying that will this, I think he's pointing to the tactical forking, will this impact the developer's knowledge because he will not have a look at all the code and he will only be focused on a specific part of the application?
This is where I mentioned that you have to inherit, to hand over all the knowledge, because you have to also understand the other domains, intersection points. So from business perspective, you have to understand if, during the handover, which is your domain as a team, and also which other domains you're going to integrate and require data from. So overall, the overall sessions, when division happens, the whole team should be sit alongside all of them. So you will have this handover and understanding. And then you take your part and you start working on it. There is a new additional technical component. Maybe you have experience with it, or maybe they are new to you, then you will have learning curve. So this definitely different from just building one application. So one application will not require, message broker and API gateway and authorization server, and then you will have scaling out and in. Then you need, even though might have a server and one database like instance, and you're just connecting them, then suddenly you find that you have to deploy all of this in cloud. So it will affect definitely, but it's a good time to have learning. And this is where also presentation is not only for developers, this is for business people also, to understand that everything has impact and there is a learning curve. So you have to put it into your plan as well, not just the feature. There is a technical debt we will inherit from the previous. There is a shared component, as we have seen. There is a slightly time, so the people can get even to the agile methodology and the sprint and everything. So it usually takes from 2 to 3 months to adapt to the norm of the new development strategy, and then you will get into speed for that.
Sounds good. I think there's another question. Is this like a forking strategy, or is it like a must before we do this transitioning to microservice, or are there any alternatives to this?
No, this is only as I give you some criteria at the beginning. So you have monolithic application, it do its business, it's a legacy system, banking system, pension system, whatever it is. Either if it's COBOL, even if you are moving to a new language, it's COBOL always used to build mainframes and you would like to modernize your software, so are using C# or Java, for example. So in this way, it's completely, you are moving to new technology with a new model. But this is when you have something that need to grow and I need a lot of people to work on the features to enhance. Like I need a mobile application to be interfaced. I need to build a modernized web application. I need a lot of people to have the backend. So you cannot work on the same code base. So this is only applicable if you want to just start working currently into speed for legacy system or monolithic application. If you have the time and you have the way that you can your software, for example, I have a software that I built. It doesn't require to be microservices based at the beginning. There is no need, because the number of customers, and it's a green field even, by the way. So I start developing it as a modular monolith in mind. So in this way, if we found in the future that there is one module has a lot of changes, and there is, because they have parts related to AI for forecasting, another part for user input, another part, they are not related. So okay, they are separate but inside one application. So why we have to have it microservices? It doesn't do, and the demand on them, it will not be too heavy. It's just generating report and sometime, but one part could be like very heavy because it requires user input. So I have decided to use modular monoliths in order to develop from the beginning as a module separate. So the structure even inside the application is different. You have API gateway consolidating all the APIs as a REST API for these modules. The modules are completely separate. They are talking to each other internally using messages server. Why? If there is any change that I would like to do, or to have an ownership, or to just scale out one part, I can just easily extract it to microservices. But why there is no changes? They are communicating using messaging service bus first, so there is no change, the same topic and queues that you are using. Also the API, I will take the part of API, putting in another microservices. The API gateway knows to which kind of communication, just would be routing, and that's it. So I will not use tactical forking here, because my software is modular. In our case, our software is non-modular, so I cannot separate easily to continue and give it to another team to start developing. In this way, I have to have the whole base of the code just as a copy. Then I start striping out what I don't need. Then I end up with microservices based on that domain function.
Yeah, great. Sounds good. Sorry, Brother Muhammad, there is another question by Brother Ali. He's saying, is this approach supposed to have limit any addition to new features during this migration, or it can be done side by side? So I think his question is like, should we stop the business features, or should we go side by
No,
side?
this is the main feature of the strategy, that when you take a copy and you know your domain, in the same time you are adding features. While you are adding feature, you are deleting. So it's simultaneously. This is why we need tactical forking to move to the business needs into speed. It's not like if I stop means like re-evaluation and I will start architecting, evaluating. Yeah, it takes time for some specific like handover and pipeline, but based on now, if you know what you need to do, you'll go, guys, we need to make an handover, we need to understand this. But during the current development, even in the monolith, you are developing features. Yes, there is some breaking changes, and then you're handing over, you get a lot of other teams handing over, and then you start, once they understand, you start forking. So each one of the team would understand how to add a new feature to their domain specifically. Then you have your API gateway, your front end doesn't affect, and you continue so on until you finalized your stripping away of the code, make your microservices just specialized for that domain, and that's it. So it's in parallel, and this is why technical forking is needed for business growth and demanding for adding new feature quickly. That
Sounds
does
great.
not break other interface.
Sounds great. Last question by self-coder is saying, can we migrate a system to microservices one at a time? Meaning, he gave an example that if we have, for example, the budget and the capacity to move part of the system using this approach, then later on, maybe after 6 months, 1 year, we will migrate the rest of them.
What do you mean if it's monolith? What do you mean by moving part and
Yeah.
part?
For example, he's saying that if we have a notification system that has like high load, I want to remove this notification system from my monolithic application and keep it like in a separate service. And maybe I have dedicated team to that.
Ah, yes, indeed. It's based on what this is. Do you remember when I mentioned the current architecture I do for one of the application for quality? So if even though I don't have this kind of like modular development of the architecture at the beginning, then I will have another copy, and just only to extract this kind of like notification system, make it separate, which is, yes, indeed, it should be separate. It shouldn't be, because this is will be off the shelf component that you can use for all the other systems. So if they need more notifications to handle notifications, they will go through this component. So you don't need to repeat the development in each and every single application. So yes, you can take this part, deploy it, and once you're confident that this part is reliable now and can work, you can switch from your internal application to start integrate with the new one and remove the old notification things from inside your application. But you have to do it in parallel. You cannot just, you take the fork, you work in parallel, you make sure it's working. When you switch, it's done, then you remove the old code. So your business continuity is still maintained. This is very important for business. You don't break anything.
Yeah, sounds good. Great. I think there are no other questions. I think here we are ending the session with
Actually,
our speaker. Yes.
I would like to thank the attendees because they have a very, very, very good and great questions. It means that I hope so, they get some benefits from the presentation. And thank you for the questions, because I like so much questions and good questions. So thank you.
Thank you so much, Brother Muhammad Taman. It was really pleasure having you in our JUG. And we, inshallah, promise you, inshallah, this is not the first and last one. We will keep, inshallah, great sessions with you, inshallah.
Inshallah. I will be glad always to join and speak in Riyadh Java user group.
Thank you so much. Thanks, audience.
Have a
Appreciate
nice
it.
day.
Thank you.
Have a nice evening, afternoon, or whatever it is you're part of the world. See you next and different time. Thank you very much. Thank you, Moaz, for having me again. It was really a great pleasure. Bye.
Thank you so much. Assalamu alaikum.
عليكم السلام ورحمة الله وبركاته.